All right, guys, welcome back to Math Analysis. Actually here on camera today in the classroom. Exciting, I know. What we're going to be working on is this right here. We're going to continue on with the molar mass packet, stoichiometry, if you will, that we started yesterday. So we did a couple of these problems yesterday. What we are going to do today is talk about some problems like 7 and 11. Problems that look a little weird. I'm going to write one of them on the board here. We're going to write number 11. It looks like this. NH4 in parentheses 2 SO4. So here's the deal. This is written a little unusually, right? This is written a little differently because we have some parentheses in here. Now, I think all of us know enough about chemistry through physical science or whatever other classes you've worked with it in to know that these subscripts tell us how many of an element there is. For example, there's 4 oxygen right there, right? That's what it means. Not having a subscript after silicon means there's just one of those. Actually, that's sulfur, sorry. However, we have NH4 in parentheses, and then we have a 2 outside of that. So the question is, what does that mean? What this 2 right here tells us is that there are 2 of the molecule in the parentheses. So we have NH4, but this is telling us there's actually 2 NH4 molecules. Now, what I personally like to do with this, what I think is the easiest way for me to realize how many total atoms of each of these there are, is I take this number and you can distribute it to each of these subscripts. So you say, okay, currently we have 1 nitrogen, right? Well, if there's 2 of these molecules, that means there's actually 2 nitrogen. And if we had 4 hydrogen in the original molecule, but there's 2 of them, 2 times 4 means we actually have 8 hydrogen. And what we can do is if we multiply that subscript outside of the parentheses into the elements in the parentheses, then we can remove that entirely. And we see that in reality we have 2 nitrogen, 8 hydrogen, 1 sulfur, and 4 oxygen. We also see this on question number 7. It has OH in parentheses with a 2 on the outside. That 2 would just distribute into the O and the H, giving us 2 oxygen and 2 hydrogen. So really, it's kind of like a coefficient or just a multiplier to that molecule inside those parentheses. So if we wanted to find the molar mass of this molecule, what we would need to do is say we have 2 nitrogen. Well, what is the atomic mass or just the mass of nitrogen? And we have 2 of those, so that's going to be times 2. We have 8 hydrogen. What's the mass of hydrogen? So we're going to have that times 8. 1 sulfur. So that's just going to be times 1. And then oxygen, but we have 4 of those. So let me consult my periodic table that I have here. And we see nitrogen is 14.01. We're just going to round to the 10th, so we're going to say 14. Hydrogen is 1. Sulfur is 32.7, so we're going to round that 32.1, and oxygen is 16. So if we have all of this, I'll put in my calculator here. 14 times 2 is going to give us a total of 28 grams of nitrogen. 1 times 8 is going to give us 8 grams of hydrogen. 32.1, we just have a single sulfur atom. And then 16 times 4 is 64, I think. So we have 64 grams of oxygen. All of this together, 28, 8, 32.1, and 64, is going to tell us the molar mass of this compound is 132.1 grams. All right, what I'd like you guys to try out on this packet is the remaining problems on that first page. I know there's several of them, but most of this math is really just addition and a little multiplication. So it's not the most complex thing in the world. I think you'll be fine. However, if you have any questions at all, need help, anything like that, email me and we'll work it out. Otherwise, I'll see you guys tomorrow.